Okay, we're in section 3.3, and this is problem number 1, and I believe it's talking about z-scores. And basically, the z-score just tells you how the data is arranged in its relationship to the mean. They can be standardized z-scores, or they can just be z-scores that are not standardized. But let's look at the problem and see what we're doing here. It says researchers measured the data speeds for a particular smartphone carrier at 50 airports. The highest speed measured 75.9. The complete list of 50 data speeds has a mean of 17.09 and a standard deviation of 37.56. Mbps, that's the measurement, the speed. A here says, what is the difference between the carrier's highest data speed and the mean of all 50 speeds? Okay, well, here's your basic calculator over here. You're just going to make a calculation. You're going to take this high speed right here, 75.9, and you're going to subtract the 17.09. And that gave me 58.81. That was the only thing it was asking me to do at this point. Okay, now for B, the difference is blank standard deviations. Okay, how many standard deviations? Well, what is the standard deviation? It's 37.56. So take this difference that we have now and divide it by the actual standard deviation. Okay, and now it says to round it to 2 decimal places because most z-scores are rounded to 2 decimal places. So 1.57. Okay. The z-score. The z-score is the same thing. Since this was a larger, it's a positive z-score, and the z-score is literally the number of standard deviations that entry is from the mean. So 1.57. The carrier's highest data speed is significantly high, not significant, or significantly low. As long as it's within 2 standard deviations, we say there's no real significant difference. And since 1.57 is less than 2, we will say it's not significant. Okay.